All right, my name is Grundler. I'm from Aitech Systems. Aitech Systems, here you go. It's very interesting. A lot of people ask me, wow, you guys have the name Aitech. You guys just changed your name recently, didn't you? And the reality is this company was started, it's 42 years now. 42 years ago, a young man graduated from UCLA with a master's in AI, and his dream was to change the world and that all farms would be run by machinery controlled by AI computers. So he developed his first computers, and of course the military took a very high interest in these computers, and that's been the story of Aitech kind of ever since. And about 30 years ago, we made some friends at NASA, and they invited us to participate in the International Space Station. And so we've been involved in space ever since then as well too. And so something like 2 trillion miles plus. And ask me about this pin later on. I'll tell you a story about another 4 billion miles and without any errors. So that's really impressive kind of history that Aitech has. But what's important is the whole backbone of Aitech is these open specifications and systems built on these open specifications. And the next system we're going to build is going to be based on OpenVPX, and it's really transforming the way space operations are working, and it's providing the additional bandwidth that everyone's needing. If you take a look at this picture right here, this picture is Orbital Express. Orbital Express launched in 2007, and it was one of the DARPA's first demonstrations of one satellite servicing another satellite. And we were involved in this program as well too, and provide the C&DH for it. And this was again a specification based, but it was the compact PCI based system. It was one of the first compact PCI based systems, and that really kind of led the way for space adopting compact PCI, and they still use it today. And people at NASA still call me up today and ask me about compact PCI based systems because of the reliability that it's really shown. So we're going to talk about the open standards, especially OpenVPX, and about how it helps these different points here in my slide. We're going to talk about the space digital backbone. We're going to talk about a systems-based approach using these open systems, and we'll also talk about the next generation of open standards of hardware. I have a background in AI. I've been involved, I would say, kind of loosely with AI for probably more than the last 10 years, and we'll talk a little bit about AI enablement in space, and I have some implementation examples. My stories aren't as good as Jerry's boating stories, but I do have some stories about some space applications that are quite interesting. And somebody pull me off the stage if I'm getting too long on the presentation. So one of the great things that open standards bring is this unified data architecture, and we've kind of named this the space digital backbone. This is from military applications. They love to talk about a digital backbone. And what it really does is it leverages these COTS applications and allows for the connectivity for you to assemble systems in kind of an easy, quick fashion. And then it'll allow to add things like network attack storaging, computing with AI and ML, and I'll have some examples of that later, and obviously security. And it really brings the modularity, scalability, interoperability, and maintainability as well too. This really kind of strengthens the space business model. One of the great things about space is we've kind of rolled into this space 2.0, and here I'm showing the Heavy Falcon rockets landing again after they've just done a launch. And this is all done with AI and mainly off-the-shelf kind of computing platforms, right? So being able to leverage these open standards, we're able to build these different systems, including command and data handling systems, Earth observation, handle communication, power control, and robotics with vision and things like that. So we'll talk a little bit about this in the presentation, and thankfully some of the other presenters set me up a little bit, and they talked about AI as well too, so hopefully what I'm talking about won't be so new to you. One of the things that we're involved in is always looking, what's going to be the next single board computer. We've had the SP0, which was very successful, and we're going to move on with another single board computer based on OpenVPX called the SP1. I knew you guys were waiting for that, right? It'll have improved computational, basically a quad-core ARM processor, and then networking and other things as well too that will leverage these standards. And for those of you who are a little bit more technical, I have a block diagram for you on the next slide here. And I think what we really, what people kind of focus on at first is the quad-core A72 processors, and then you kind of look down to the connectivity. And this connectivity with Ethernet and PCI Express really opens itself up to being adopted with OpenVPX for the backplane, or you could also use Space VPX, which is kind of a derivative of OpenVPX as well too. And we're working on both of those for this application. So one of the things that we looked at when we talked about OpenVPX, you get this additional bandwidth, so what can you do with this additional bandwidth in the backplane? And one of the things is that you can leverage AI implementations. And so by using this kind of standardized 3U VPX architecture, you're allowed to integrate these complex AI processing hardware, and I'll have a little bit of discussion, some slides about those as well too coming up. And one of the interesting things as well too is everybody talks about GPUs, and of course the conversation of NVIDIA comes up, and we'll talk a little bit about that. And it provides a really good rugged baseline to leverage Space VPX when that's required or heavily adopted. Currently right now for LEO applications where redundancy is not required, most people are using OpenVPX because it's less expensive, less weight, cheaper to fly into space. And then for redundant applications where you're going to like Mars or Europa or someplace complex or difficult, people are looking at Space VPX, and we'll do the same when we're working together with our customers as well too. So these open standards are really, really being leveraged to help people integrate these products together to create these very interesting AI systems. All right, so I think one of the things that people often ask me about also is, what is AI? And so does anybody get that question here when you, nobody? Okay, well, maybe I'm the only one. But you can tell people AI is just data. That's all that AI is. And AI manipulation has been around for about 50 years. The problem is the math was there, but the computational power is not. And now we've finally reached in our society to where we not only have the math and the computational power, but we also have the data. And one of the probably most famous things is ChatGPT, which trained itself on all the internet data, right? So think about ChatGPT as just a word prediction program. So it's just predicting what the next word is, but by training on all the data available in the internet, it can write sentences and paragraphs and respond to you in almost like this weird human way application. And everybody's like, oh, ChatGPT is going to take over the world, but you also have to tell them that it already trained itself on all the data in the world. There's nothing new it's going to learn, so you don't have to worry about that. So this is what this slide's about is, how do you go about using AI in your applications? And you have to choose the right model, and then you have to have a data set. One of the things that about ChatGPT is it'll have what they call hallucinations, right? And that's because all the data on the internet isn't vetted, right? It's not necessarily 100% accurate. So you need to make sure the data that you have has been labeled properly and been vetted to be correct, right? Because you don't want your spaceship going off in the wrong direction because of bad data. One of the famous stories is when AI was first being developed, they did this training on identifying cars. And one of the cars was red, and so they wanted to identify all the red cars. And so it turned out there was a cloud in every picture with a red car, so the AI just focused on the clouds. So if you wanted to find a red car, it had to have a cloud in it. So that's the very important part about data labeling, and this is a whole business in itself. If you go out and try and buy data for AI training, which is the next step, you'll find that it's very expensive to buy this data. So there's different kinds of training that you can do on your data. There's transfer learning and online learning. In the end, because of space, there's not so much data, we're going to have to do some kind of fine tuning. And what that is where you take a piece of data that you've collected and then you compare it to your data set and see if it fits into your data set, and then you add it into your training. And so it's this kind of iterative process. And that's what our friend Elon Musk is doing. That's why people are like, oh my God, he shot up this rocket and exploded. And everybody at SpaceX is going, great, we just collected a bunch of data of a failure that we don't want to follow, right? So it's actually a very valuable piece of information. So think about data in that kind of concept, then all of a sudden you'll realize what he's doing is actually very smart in terms of collecting the data and being able to predict what not to do as well as what to do in terms of his training model. So then you'll deploy it and you'll do monitoring, and then you'll be able to have some kind of real-time analysis and action for your mission to make sure it's successful and safe. So, everybody's asked also, there's two points here on this slide. Everybody asks, well, what is, AI at the edge for space going to do for me? And one of the things that it allows is, it allows you to be able to process the data on the satellite itself or on the spaceship itself, rather than downloading it to a stronger computer that has the ability to do the data processing and then uplinking the data again. So now you can observe what's happening, provide that information directly as a downlink, but it would be just the simple, like for example, instead of knowing where a whale is, you would just give the coordinates of the whale and what it's doing, right? It would be some kind of simple data that you could transmit down. And that's really the advantage of having AI on the edge in a spaceship, because as everybody here knows in the room, the downlink is really going to be the problem with satellites, right? If you have thousands of satellites, they're not going to be able to all download these high-res pictures all at the same time. So the other point here on this slide is there's a lot of different hardware data processing solutions. GPUs offer that parallel processing, and we have some NVIDIA applications that I'll share with you, actually some success stories. The other one that's interesting as well too are neural networks, and neural networks are great because they're very low in power, and they also provide this hardware efficiency because of that low power. And then you can optimize communications or videos or other things with neural networks, but they're a little bit more fine-tuned. And then the final one that we know from past history is that processors will integrate instructions in order to handle AI capabilities. And so if you think about what AI is you're really comparing two data sets. So it's either a vector multiplier or a matrix multiplier that you would accelerate inside the processor. And that's what our friends at the RISC-V committees have done. They've added these vector extensions for AI. And so people are looking at AI and RISC-V as a solution for satellites. And I'll push the button, there we go. So one of the things that people should always evaluate as well too is once you have your data set, you need to evaluate what kind of algorithms that you want to address, right? And there's different algorithms literally for everything. And so when you hear about these open source algorithms being published almost like on a daily kind of thing, they're typically for very specific applications. And so looking at the correct algorithm is really important in terms of whether you're trying to address anomalies or managing risk. And then of course, for anything with the kill button, you want to make sure there's probably human in the loop for that. So the types of algorithms that you're gonna look at is really, really important before you start your journey into AI as well too. So this is just kind of one example of what you can do with AI. And the word that people kind of are starting to throw around now is called transformative AI. This is where we're going to like change the world with AI, right? This is just kind of a really small example here where they're talking about methane gas emissions. And you can see that some are much higher than reported and others are lower than reported. And so you can accurately predict these kinds of things. And so these are satellite-based observations. You can do things like manage climate change, identify the reporting discrepancies like I showed here with methane. You can also track changes on land. For example, how is the ocean level rising and covering lakes? Or it probably won't quite show any shoals in the Mississippi River, but you can track different changes like that. And also, especially really important for us nowadays with climate change is weather patterns as well too. And so obviously for the warfighter, you can track your enemies, over the horizon. So you have this view that's way beyond the horizon. So the thing that really increases the mission resilience, is onboard decision making. And this really allows you to reduce human intervention. In fact, one of the samples I show is one of the first autonomous satellites that are flying with very low kind of human interaction. It allows you to have kind of more a critical focus area. For one example for using AI is debris avoidance, right? So NASA will track everything that's 10 centimeters or larger, but for the smaller stuff, you'll need to have some kind of way of tracking this data. We already know about optimized landings from SpaceX. They've shown us how to do that, but think about landing on a remote planet, right? That's a whole different application that we're working on, right? And then you can alter the orbits of your satellite or even trajectories so that you would line up over Earth to view some particular object that you're interested in. So this is about NASA Lofted, and they did a lot of data processing for their Lofted re-entry vehicle. So this is an inflatable re-entry vehicle. It's really cool. So it goes up all compressed. You inflate it in space, and then you re-enter. So one of the things that they wanted to test was the skin of this re-entry vehicle to make sure it didn't burn up. Everybody had seen the space shuttle issues, and so they wanted to do that. And so once you're starting to gather this much kind of camera data, you need some way of processing it. And they used an NVIDIA GPU. It's called the Jetson TX2i. It has, I think, something like in the order of 200 CUDA cores. And this was really one of the first uses of a GPU in space. And it was, our product name was SA1760, which doesn't mean anything to you, but just to let you know that it had up to like 6 cameras attached to it. Some of them were infrared as well too, and they're combining the images and then checking the skin of this re-entry vehicle. And they had everything, of course, backup on recording data, and then they could provide this critical intelligence on this heat shield performance. And so this is really going to be something for the future when you want things to re-entry safely. You'll be able to have this inflatable shield go up and provide you protection as you re-enter. And it's one of the cool things about working together with NASA, because they'll call you up and say, hey, we saw you had this military product on your webpage. Can you make that space ready? And so, of course, NASA makes it sound like it's so easy, of course, but after going through a lot of work with them, there's several things that you have to do to make things space ready. One of the things you don't realize is that you have to change the materials, and there's two reasons for that. There's corrosion issues in space, believe it or not, especially in low Earth orbit. And then there's also off-gassing. So when you go from one atmosphere to no atmosphere, all the material is going to be expunged from whatever product that you have there, and you don't want that to coat, for example, your solar panels, because that would be bad. So you have to go through things like that in order to make things space ready. And so once we provided to NASA, other people saw this, and Citispace was one of our first customers to get this product up into space. And it's really one of the first in-flight autonomous systems for a software mission. They launched in March of 2024. Does anybody remember what happened in March of 2024? You guys saw the auroras. Remember that? All those beautiful auroras, what are those? Those are solar flares. So it's tons of radiation raining down basically on Earth, right? And so, luckily I shouldn't say luckily because we actually planned for it. We planned for heavy radiation on our hardware, and our hardware was very resilient for this application. And they actually, one of the things that they had to do is they hadn't actually quite finished their software before the launch. And so they had to reload their software and reboot the satellite several times before they were able to deploy the solar panels and get everything in operation. So being able to do that testing and working together with NASA and having the 30 years of experience allowed us to be able to prepare for this kind of worst case situation and have a successful flight. There was a lot of other satellites on this launch, and I won't mention their names, but they were not successful because they were just taking the Elon Musk kind of approach that, we own all the uplift, I can just shoot up another satellite if something fails. And they realized that was kind of an expensive mistake because they're not Elon Musk, of course, right? So, yeah, this is my last slide, and this is the wrap-up slide. This is actually an extremely interesting project here. This was Intuitive Machines. They did the lunar lander. We didn't build the legs, so we had nothing to do with that. And what actually happened is they had kind of a sonar device where they forgot to remove before flight tab, and so they had to actually use one of their payloads to land, and so that's why the landing was a little bit difficult. But they were able to collect all the data that their payloads were allowed, and they got paid very well. And they were very successful with this. And if you ever get a chance, go down to Houston. It's just a little hop, skip, and a jump from here. Was it a 1 hour flight, I think, right? And they actually have this on display, and you can see their stuff, but they're doing very, very well. So OpenVPX transforms space operations. I think we've proven it at Aitech. And we look forward to working together with people to support this digital backbone and help into space.